Assalamu alaikum. My name is Abdur Rafay and my partner name is M.RehmnKhaliq. Today we will give you a presentation that is based on the topic the Bellman-Ford, and today I will give you concept and the key features of Bellman-Ford's, the application of Bellman-Ford's pseudocode, advantage and disadvantage. So then we go to next slide, that is our introduction. So first of all, the Bellman-Ford introduction is the Bellman-Ford algorithm computes shortest path from a single source vertex to all other vertices in a weighted diagram. It means to say that suppose we have a graph in which we have a nodes, in which we have the first of all we have a source node and other we have a nodes, and we assume the value of source value is 0 and the other node value is infinity. We have to know, we have to find the shortest path from our single source, and we write the value about the weighted graph. It is just unlike the digestive algorithm, it can handle negative h weights and also detect the negative weight cycle. And then we go to next slide. So our next slide is key features. Key concept of Bellman-Ford is work on directed graph. It's handle the negative weights. Its complexity is big O V multiply E. The space complexity is big O V. And the application of the Bellman-Ford is routing protocols, rest in peace in networking, and currency arbitrage detection, evaluating shortest path in graphs with possible negative weights. It can evaluate the shortest path from the source to other nodes and from others in a directed graph, and if we have the possible negative values, means to say that if we have a values less than from infinity, we have to find the shortest path, and we can conclude the values and according to our shortest path. And then we have algorithm steps. First, we initialize the distance to all vertices as infinity, as I already said in the previous slide, and the distance to source as 0. Relax all edges. In the Bellman-Ford, we have to relax all edges v minus 1 times. Suppose if we have a 3 edges, 3 vertices, it's according to formula v minus 1, 3 minus 1 is equal to 2. We have to relax the 2 edges, 2 times edges, and we conclude the Bellman-Ford according to this algorithm. For each edge uv, if this u plus weight uv less than Dijkstra v, the update Dijkstra v. If in the Bellman-Ford we check the negative weight cycles. Here we have a pseudocodes in which we implement the function of Bellman-Ford graphs and initialize the distance source, and in which we initialize the loop from I from 1 to v minus 1 from each edge, and then we apply the formula from the distance to the weight. If we have the distance it's less than weight, sum with weight, and it's less than this from our distance, so we write the value of the distance. For each edge uv in each distance, according as we already said, negative weight cycle is detected. If the distance and weight is sum and it's less than from the distance, so that the negative weight cycle is detected. Here are the key examples of the Bellman-Ford. The first one is provide a simple graph for 5 vertices and step-by-step realization process according to the formula v minus 1, and we have to find the final shortest distance according to the graph. And here we have the advantage. In the advantage of Bellman-Ford, we can detect the negative cycles, and it is more versatile than Dijkstra in graph with negative weights, and we have to find the negative cycles and to find the minimum distance according from the source to our nodes, and it is also more versatile than Dijkstra in graph with negative weights. And then we go to next slide, that is about to disadvantage. Actually, it is slower than Dijkstra algorithm for graphs without negative weights. if the Bellman-Ford is without negative weights, so it is slower than the Dijkstra graph, and it is not suitable for the real-time application with large graphs. If we have a large graph and we note it is not suitable for real-time application, we can conclude the value. And we already discussed the complexity of the Bellman-Ford in the previous slide, time and space complexity. The time complexity is big O V multiply E, and the space complexity big O V. If we comparison with the Dijkstra graph, the Dijkstra is big O E plus V log with a minimum height. And at the end we have a conclusion. Bellman-Ford is a fundamental algorithm in a graph theory, essential for scenarios with negative edge weights. If we have a negative edge weights scenarios, we can apply the Bellman-Ford algorithm, and we can find the minimum distance from the source to the other nodes, and it is much slower in than Dijkstra graph. That is the main disadvantage. It provides more functionality in certain contexts. Thank you.